Without further ado, Mayo and Nuno, please take it away. Yeah.
Can everyone see my screen? The slides?
Yes, we can.
Great. Right, so let's get started. So today we want to talk a little bit about what it takes to build reliable agents with LLMs and how LangChain and LangGraph can help with that. Um, a little bit about why kind of this is interesting and important. I think LLMs unlock things that we simply couldn't build 2 years ago. It's just a, new capability that's quite different from what existed before. And you can simply build things now that you couldn't build 2 years ago. And that, at least for me, is super exciting for me as a builder. But it also raises new questions about how to build applications effectively and successfully. And this is because LLMs are actually pretty different from previous software in a few ways. And that's kind of what we want to talk about today. First, just a little bit about LangChain. The original LangChain library was launched 1 month before ChatGPT, which is a very long time ago in the AI world. Still going strong with over 75 million monthly downloads. We recently crossed the OpenAI SDK in downloads. So we now have more downloads than them, which is great. Since then, we've also done a bunch more things in the LLM space and observability, evals, orchestration, deployment, and so on. But enough of that. I think let's just jump right into the challenges of building reliable things with LLMs. I think good to remember that LLMs have already unlocked a number of really interesting use cases. So you can see LLM agents being used as co-pilots in different spaces like hiring, talent, databases like Elastic and CodeGen. That's a very popular use case. Search for e-commerce and other things. Internal enterprise kind of helpers, investment research, customer support, and the list goes on. And this, I think, is a good reminder that you can actually build new things with LLMs, and that's why this is such an important topic. But building with LLMs is actually hard. You can't always get what you want, as LLMs are actually, unlike all previous software, they're non-deterministic, and you have to learn how to make the best of that, because that is actually what enables the new use cases that you can build with LLMs, but it also invalidates a lot of the expertise that we've accumulated in building software. So let's dive in. The first challenge that I want to talk about when it comes to building with LLMs is that LLMs and applications built with LLMs are slow. So we've been used to measuring the time, the latency of the backend endpoints, servers that we write in milliseconds. That's, when we were building up until 2 years ago, or, even now, we always want to, minimize the latency of what we build, and we measure that stuff in milliseconds because that's kind of the order of magnitude that that regular software operates in. But with LLMs, you actually end up having to measure the latency of LLM agents in seconds or minutes or sometimes even hours. And this actually has gotten worse over time, not better, which is can sound surprising at first. So you see the newest agents from OpenAI or others like Deep Research, they now take 30 minutes to give you a reply. Whereas ChatGPT that you were using a year and a half ago would give you a reply in like 5 seconds. And this may sound bad, but it's actually part of what makes LLMs powerful and allows you to build new things, is just giving them the time to think about what they're doing with all the stuff out there about test time compute that actually unlocks new capabilities. So this slowness is not something that you want to eliminate. It's something that you want to take advantage of. some of the reasons why, in addition to just the models, being taking their time to give you the answer, there are other reasons that actually make LLM agents slow. One reason is many times you need multiple LLM calls to achieve your results. So, for instance, a very popular architecture that powers all the agents that use tools is looping. So you loop your LLM calls in order to have the LLM be able to decide when it wants to stop thinking about the problem and giving you the final answer. And that's really powerful, and you shouldn't remove that capability. You just need to learn to work with it and work around it. Another reason is that you actually need non-LLM steps before or after and after your LLM prompts. And this is for a number of reasons. I think the main ones are before you make your calls to your LLM, you need to call other systems to build the context that's going to be thrown into the prompt. So this is stuff like RAG, fetching relevant documents to put into the prompt, or doing database queries, or doing web searches, or other things like that that help you give the LLM the right context to make that prompt be the best it can be to answer the question you have. And after your LLM call, you also need non-LLM steps. And this is very often for the purposes of guardrailing, to check that the output you got from the LLM is safe to show to the user, or is according to some guidelines you have, or is actually correct, because many times that's another issue that I will talk about soon, but LLMs are non-deterministic, so it actually helps a lot to have some checks on what they produce to make sure it seems correct. But this is all, super powerful and is what enables LLMs to solve all these problems. But you actually do need to think about how to keep users engaged while they're waiting for the results. And there's basically two main strategies you can use to solve this challenge. One is a lot of these steps, not all, but some can be parallelized. And that really helps. The more you can do stuff in parallel, the less the overall latency is going to be. And another really important one that just wasn't a thing 2 years ago before LLMs is just streaming intermediate output. This is super important for when you're building with LLMs. And you can even see, I remember some early versions of I think it was Bard, the Google chatbot that is now Gemini, didn't have streaming, and it just felt super awkward to use it when compared to, say, ChatGPT, where you see like the response streaming in word by word. There is actually another challenge that comes with LLMs being slow, and this challenge is the simple fact that all software fails. This is true. This has always been true. And will always be true. It doesn't matter if it uses LLMs or not. You always will have failures, and you'll need to retry things. But because LLM software is slower, and it has more steps, it actually means that it will fail more often. So you're going to have to retry more often, and each retry is going to cost you more, because if you don't do something about it and you retry a slow process from the beginning, that is just going to compound into taking more and more time to get the right answer. So there's two main strategies you can use to minimize this. One is to run your agents in background workers as much as you can, because that just disconnects the running of the agent from whatever triggered it, and it means there's one less source of failure. So it reduces the number of retries needed. And the second one is, if you checkpoint intermediate work, that actually can reduce the effort needed for each retry. Because when things go wrong, instead of starting again from the beginning, you can start from the last successful step. And that means you can get to the end successfully much faster. Then the next challenge, or kind of set of challenges, is that LLMs have what I would call open-ended I/O, so input-output. And let me unpack this. So on the input side, it's actually super helpful that LLMs have this kind of ability to handle open-ended input. And what this means is simply that you can ask your question to ChatGPT or whatever other LLM application in slightly different ways. You don't need to use the exact word as a very exact word to trigger the exact response you're after. You can just write a variation of what you're after, and it will many times result in similar results. And that's great, because that's how humans work. Like, we're not machines. We talk to people, and we say things in imprecise ways. And LLMs are great because they can actually deal with this imprecise input. And this wasn't true of previous software. But kind of the other side of this coin is you also get open-ended or unreliable output, where the exact same prompt may not always produce the same result. And when you combine these two things, you get some maybe surprising behavior, where the application that you built and that you tested while you were building can actually end up behaving somewhat differently, or pretty differently, when you put it in production, because your production users are going to interact with it in ways that you didn't necessarily predict, because they have different ways of thinking, and they come with different biases. So they will prompt your application in slightly different ways that maybe weren't the ones that you tried when you were developing it. And that kind of creates the need for some way to deal with that variety. There's two important strategies that you can use to deal with this. One is the concept of human in the loop. So giving your LLM agent and your LLM applications the ability to delegate back to the end user when they think that's appropriate is super powerful. It means it basically turns your LLM application from just trying to get an LLM to achieve something into turning it into a collaboration between the LLM and the end user. And that's so the LLM can ask the user to clarify the original question because it wasn't well specified enough, or to review the next action that it's about to take, or review a draft that it wrote of an email before actually sending the email, or approve the next action if it's something that's destructive, like deleting a file or something. And this turns out to be super powerful, because this gives you the ability to actually build LLM applications that take meaningful action in the world in a way that you can rely on them, because that when something important that is not easy to undo is about to happen, you get the final say on whether that happens and how that happens. And the last one, more new, I would say, is the concept of generative UI. So the kind of corollary of this idea of open-ended I/O is that it's going to be hard for you to plan ahead of time everything that the user is going to ask your LLM application. So giving the LLM application, the agent, the ability to decide how to display the results to the user, basically generating the UI that's going to show results to the user, can be a quite powerful technique to make the application really successful. And that's a lot of challenges you need to think about, right? So building a custom solution that, in addition to solving your problem, the problem of the agent that you're building, while also building all of these essential features, is probably not how I'd recommend you do things. Because you want to spend your time, you want to maximize the amount of time that you spend on actually making the agent for your use case work really well. So if you can delegate to someone else, to an open source library or whatever it is, a lot of these building blocks that can really help you in building your LLM application faster. So I'll let Mayo speak about that.
Thanks, Nuno. Can you hear me? Good. All right. So as Nuno said, obviously what the challenges are and the solution we are providing or discussing in this talk would be LangGraph. So moving on to the next slide. So what is LangGraph? So LangGraph is essentially an orchestration framework. It's also a platform that enables you to build these highly customizable agents that tackle the challenges we just looked at. So it provides different pillars to do this. We have controllability. Basically, you can define workflows, and I'll go deeper in the next slides, but essentially, as you can see in the image on the right, a workflow constitutes of a start point. It's just a point to signify to the agent, this is the start of this particular workflow. And then the different points or the different nodes of the workflow basically define an action that the agent is going to take. So whatever the particular use case you have, this kind of gives a lot of control, so you can define every single step of the agent is going to take. And then we also have a special point called an end as well. So this helps you to build different for different use cases, no matter how complex you can imagine, and also will be very useful when you want to debug each step and see what went wrong or evaluate and test performance. We also have streaming, which I'll discuss shortly, tackling one of the issues Nuno mentioned, where you can see each event or each token as they emitted. Persistence is important because most of these applications we're building, not just for chat capabilities where you need to keep track of chat messages, both in the short term while the user is interacting with the application, but also persistent across different sessions. The user closes the tab, or they log in and log out. You want to persist that. But with an agent, you also want the agent to have memory, to be able to, for example, it might have memory of the preferences of the user as well. So then the next thing we have here is human in the loop. So a situation where, for example, the agent wants to log in, we would need a way to provide authentication permission so that the user can authorize that they want to log in and the agent can continue the process. We also see coding agents do this as well. So if you've ever used Cursor or Windsurf, before you perform a destructive act, whether it's deleting directories or creating new files, the agent will stop you and say, do you want to go ahead and run this command? So LangGraph is also integrates with other tools and products that LangChain provides, including LangSmith. So LangSmith is a natural observability and evaluations UI and application that links seamlessly with LangGraph. So this enables you to test your agents before you launch, monitor the results of each step, and essentially improve the performance of your agent, making it more reliable. So yeah, so this is just more of a granular look at what's actually happening with LangGraph. So as I said, you have a start, which is a special point, a special node, this defining the starting point of your workflow. So let's use a very simple example of a customer support chatbot. You would have a start point, and then you would have the first node, which is just, what is the action that this agent is going to take? So maybe the first node is just something very basic, like perform RAG and go fetch information from your customer support documents based on the user's input. LangGraph also defines what's known as edges, and edge is just basically a connection between two different nodes. So where one node might be, for example, going to ingest maybe the customer support documents, another node might be responsible for retrieving the documents, the relevant documents based on the user's input. And LangGraph also provides what's known as conditional edges. So conditional edge is more or less you can think of as an if-else statement, where we are essentially giving the agent the choice to classify. It might, for example, classify an input that a user provides and say, okay, based on this input, I'm going to go this way or that way. So just having a node, an edge, and conditional edges, these special start endpoints allows us to, as I said, build these complex agents. And then, yeah, obviously this is just a, in addition to the image, just to kind of simplify it a bit more. So we can move on to the next slide. All right, cool. So Nuno also touched on different, with the other concepts he touched on as well. One very important feature the LangGraph has is shared graph state. The state essentially is just, you can think of data structure, an object, a snapshot of what is held by the node at that particular point in time. So a very good example of this would just be keeping track of user messages across the entire workflow. So we can see before we hit node, the user said hello, and the node in this case would be, sending the user's input to the LLM to generate the results, and then we can see the new state afterwards. This is very useful, again, because one of the challenges with building reliable AI agents is being able to get very granular and to see what's really going on under the hood for every single step. So I think that is a very, very big benefit here, because you can debug, you can see exactly what's going on. There's no guesswork, and it makes things very, a lot more reliable. And so LangGraph can actually have workflows or graphs that are subgraphs. So a subgraph you can think of as a graph within a graph. A good example of this would be, for example, let's say you're trying to replicate deep research, so ChatGPT's deep research, which goes to the web, gathers all this information, and then creates this very comprehensive report for you. Now, for example, you might, if you were trying to build your version of this, you might have one agent who is the supervisor, and this supervisor agent, the job of this supervisor agent is to orchestrate these other agents who will be responsible for different things. Maybe one of them is responsible for getting the source links related to your topic of interest. Another agent might be responsible for creating the draft of your deep research results. And then the third one might be responsible for essentially editing your document. So you have the supervisor, and then you have all these different sub-agents, and then each sub-agent, you can create a subgraph for them. So you have your main graph, and then you have your subgraphs, which represent each agent. And so, yeah, this is just more of a more detailed, showing the possibilities of what can be built with LangGraph is these kind of, very complex architectural patterns. You can see I showed the supervisor example was what I just used when I was just explaining, but you can also see, hierarchical, all kinds of complex structures depending on the use case that you're interested in. And then also Nuno touched on streaming, obviously good for UI, UX as well. And you can see, what LangGraph does is each event, each node, each token streamed by the LLM is provided to you, not just in terms of UI, UX, which is very important, but it also very good for you to see from a development and debugging point of view. And this is where Langsmith comes in, because Langsmith will integrate seamlessly with LangGraph. You can do the testing and debugging beforehand, and all these capabilities are supported in the observability and evaluation provided by Langsmith as well. So yeah, this is just kind of showing how streaming progresses throughout the app. Okay, and the next very important thing here is persistence. As I touched on briefly, you need persistence not just for keeping track of chat history, but also for giving the agent some sort of sense of who the user is. For example, like I said, in a customer support agent case, maybe the customer support AI agent is able to keep track of the user's, types of questions they ask, or their email, their preferences, and so on. And this just makes the experience a lot more seamless. It makes it almost human-like, because the agent is able to keep track of these states at different points in the node, and also whatever conversation it's had with the user. So it makes it more human-like in terms of the way you build these AI agents. And yeah, of course, persistence enables fault tolerance. So this, will also help you to essentially set up these different checkpoints and be able to know where errors occur and to prevent them from happening in the live production application. And then what LangGraph does essentially is it takes each point of the graph. So you have these nodes, and each node, like I said, is able to capture state, state being whatever you define state to be. Maybe you want to keep track of the messages, maybe you want to keep track of anything you want to keep track of throughout the duration of the graph. And these checkpoints essentially culminate together to create a thread. And so because we have these threads that have captured each state of the conversation, we can persist conversations both in the short term and long run. So you can then store these threads in your database, and when a user goes back to a particular page, you can then fetch the thread and repopulate with all the prior conversations that happened. And so, yeah, this again, just kind of trying to capture the point I just made. We're able to maintain both short-term and long-term memory to enable your user to have a much better experience. And of course, very important, human loop, as I said, authentication, permission, or if you're building coding applications, permission to run commands. If you're doing any sort of AI agentic application that has sensitive steps, LangGraph provides this inbuilt function known as interrupt. It stops the workflow at that particular point, and it waits for an input from an external system, and that would be shown in the UI as some sort of way of prompting the user to provide permission. And then once the user provides permission, then we can go to the next step in the node. And this can be a conditional edge. You can have sometimes, for example, if you have a human loop interrupt that involves revising the input, then you can also have a conditional edge that will effectively re-loop back to where it came from and maybe regenerate the results. So maybe this would be good for a case where the agent creates a report of some kind. If the user says, no, I'm not happy with this, edit it again, we will just loop back to the previous node and regenerate this. All right, Nuno, I think can jump back in.
Cool. Yeah, so thanks for that, Mayo. So now to recap, just wanted to finish by kind of remembering all the solutions that we have to deal with these challenges that show up when we try and build with LLMs. So first is parallelize steps where possible. So where two steps don't, depend on each other, you can save actual latency by running them at the same time. The second one is to stream intermediate output. And this doesn't save any actual latency, but it really works on reducing the perceived latency for the user, because the user sees something going on. And next is to run your agents and background workers as much as possible, because that's going to reduce the need, the number of retries that you're going to have to do to get to the end successfully. Second is to do some kind of snapshotting or checkpointing of intermediate work so that you reduce the effort needed when you do need to retry. Then human in the loop is really, really important to delegate back to the user to clarify, review, approve, reject, and so on. And finally, generative UI is a kind of an up-and-coming solution to let LLMs decide how to display the results of their work back to the user. And yeah, thank you for listening to our presentation. And now we can jump into any questions that you guys have.
Amazing. Thank you both so much. I am going to do my best to pick some of the questions that we have based off of the likes. If you are watching right now and you can see the questions, please go ahead and read through like the people in the chat and upvote the questions you would like. So I'll start with the first one. This has 16 likes, so we'll ask, how does LangGraph's approach compare to I don't know how to pronounce this word, DSPy. I know I've heard of it, DSPY. Do you have any thoughts on that?
Yeah, I can take this one. So DSPy, or however you pronounce it, is essentially it's an interesting idea. It's for optimizing your prompts, which I think is kind of a different problem than what LangGraph aims to solve. So optimizing each individual prompt is helpful, and the SPy is one way to do that, and you should check it out. And LangGraph is kind of a way to orchestrate all of your prompts and your non kind of LLM steps as well. So it doesn't matter how much you optimize your prompts, you still need to inject it with additional context for it to be successful. I would argue that's kind of the main challenge when building with LLMs, is just building out that context that you send to the LLM so that it can produce the right answer. And that always involves fetching data from external systems, or whether that's RAG for your store of documents, or a web search, or a database, anything like that. So that's kind of where LangGraph really helps. And then building out those guardrail after, so that you can be sure that the answer that was produced, no matter how optimized the prompt, you still need to make sure that the answer is good. So making sure that it's good and it's something you want to show to the end user, and so on. And then all the other stuff that we talked about that comes with like the orchestration framework. So, checkpointing, streaming, all those things. So you can use them together. It makes a lot of sense to use them together, but they're just different things.
Okay, great, great answer. The second question that has a lot of likes is from Dawn, who is great and super active in the chat. Hi, Dawn. The question is, what is your advice for practitioners to keep current in this nonstop changing world? What core principles have remained and are more important than ever, e.g., software developer best practices? And how can we best validate the tools we build? So these are three questions combined to one. I think the main one to start with is like, how do practitioners keep up? And are there some best practices for software developers that
Yeah.
translate even with changes? Yeah.
Cool. Yeah, I'll try and answer them one by one, and if I forget one, just let me know.
Okay.
So I think the main way to stay current is you just need to try things out. Like, you need to be using both kind of end user LLM applications like ChatGPT. That's actually a great way to figure out what LLMs are capable of, because that's kind of one of the main challenges of working with LLMs, is just figuring out what can they do. And that's actually not a trivial thing to figure out, because they're improving all the time. So I personally get a lot out of just using ChatGPT and Claude and Gemini and all those other things as much as possible, and trying out new use cases. Just seeing, oh, can it do this, and try that out and see if it can or if it can't. And that's one way that you can learn a lot what LLMs are good for and not good for. And then kind of after that would be to actually try and build some applications that use LLMs, doesn't matter how simple they are. And that can also, give you a lot of intuition for what are the challenges that you run into. And that's where I try and spend some of my time as well. So I
Yeah,
don't think there's, there isn't like a, an easy answer. Oh, just go on this website, read it for 5 minutes every
Yeah.
day, and you're up on everything that's going on. It's just using it.
Yeah.
just
I
to
heard Mayo. Yeah. Go ahead, Mayo, as well.
yeah, just to jump in real quick, because I mean, when I was heavily in consulting, I had different clients, different industries, and yeah, there was a time where I was on Twitter, like I'm UK time, I'm Twitter till 3 a.m. because I'm afraid of what the Americans are going to say when I'm sleeping. I mean, it's not sustainable. It's actually not healthy to be too deep into things. What I've realized over time is that, as Nuno said, once you start getting in the weeds of actually building these applications, you begin to see what's hype, what isn't hype. Another thing I found very useful is spend a lot of times in first principles, like really understand things, how things really work. I understand how RAG works under the hood, understand just the basics of function calling and all these things that are very fundamental. And so if someone comes up with some new fancy thing like MCP, you're not thrown off because it sounds so fancy and you're afraid of missing out. You're like, okay, I can see this is
Yeah.
just building on the foundations of prior knowledge. So I would really encourage that because there is a lot of hype right now about new things all the time. It's easy to get overwhelmed. So
Yeah, that's a great response. I'm on Twitter 24/7, keeping up to with what's going on. But that is absolutely correct. With first principles, that makes a lot of sense to keep up with that. Um, any other thoughts on this besides that, Mayo or Nuno?
So on the other side of the question, I think it was about like best practices.
Yeah.
Something that's helped me is trying to like draw parallels between, what were the best practices and still are, of course, for building without LLMs, and trying to see, what that maps to in this world of building with LLMs.
Mhm.
So for instance, one example would be RAG. When RAG was all the, rage 2 years ago, oh, it's a completely new thing. We need new databases, et cetera, et cetera, et cetera. But in reality, I think the story that, has surfaced over time is this is actually an old problem. It's called, search. And
Yeah.
people have been thinking about search for quite a while. And it turns out a lot of the lessons that were learned in the past few decades about search are still super relevant, maybe even more relevant now. So I think always tracking back to the best practices that existed before LLMs and applying it to building with LLMs, I think is very valuable.
Yeah, absolutely agree with that. Okay, great. Thank you both for those answers. Um, the other question I see with the next highest amounts of votes is about MCP. I have lost it just now, but it's about, I think that question was about how MCP fits in with LangGraph. Is there a way to use MCP with LangGraph? What would that look like for us today?
Yeah, absolutely. We have several integrations of between LangGraph and MCP. So we have a library called LangChain MCP adapters, which allows you to connect to an MCP server and then create tools out of that MCP server and pass those to any LangGraph thing that needs tools. And then they just work as if they were tools local to your code. So that makes it super easy to use, any remote MCP tool in your agents in LangGraph. And in LangGraph platform, we also have an MCP endpoint that allows you to expose your LangGraph agents as MCP tools for another agent to call. So that's kind of the other side of the integration. So you have integration both on using MCP and exposing things as MCP.
Great. Yes, awesome. So there's a library for that you can take a look at, which is
Yeah.
great. We do have a question from T. Harris, and this question says, what does it mean to have AI generate the UI once or continuously? Can you give an example about generative? I think, yeah, either of
Yeah,
you.
so it's a great question. I think there's different kind of stages of this. The first one would be if you have, imagine that you have like a set of UI components that you have available to render in your, let's take a chatbot as an example in your chatbot. So that would mean you have maybe, a component to render a map, a component to render images, a component to play a video, to play audio, to display tables, and so on. And then, so the kind of the first step of generative UI is to let the LLM pick from these pre-built components, hey, which one should I use to render this particular answer? That's kind of step one. I actually think this is probably the most useful right now, because having the pre-built set of components means you're, in control of how they look, so that they will all be on brand and, match the design of the rest of your application and so on. But you still give the LLM the ability to control what the user sees that is relevant to the answer that it's producing just now. And then you can extend this. Kind of the next stage is, giving the LLM the ability to generate a completely new component every time it gives an answer. And this is kind of more advanced. I definitely wouldn't start here, but it can also be useful if you if your application is needs to render stuff that's completely custom. But I would definitely not start there.
Yeah, that makes a lot of sense. Yeah, thank you. I think it's a very cool part. Generative UI seems really interesting, so feel free to test that out. I think we have probably some time for a few more questions. I see this is a bit more of a broader question from Krista. This question says, I will put it live. It says, isn't it important to avoid using human terms when describing what LLMs do, saying a system thinks or solves problems? The term agent also suggests intention and internal accountability. Such terms encourage us to anthropomorphize. Wow. I've heard several people saying this word, or humanize, I guess, a machine, and changes the fact that LLMs use computation and statistical language. So I think the question here is, what are your thoughts on using some of this human language for LLMs or these systems thinking or solving problems? Do we feel that this is a a good thing to be doing? How do we feel about this language? I don't know.
Yeah, I do think it's a oh, sorry, go ahead, Mayo.
Yeah.
Yeah. I think as there was an image I was going to put in the slides, like showing the different levels from, an agent being this kind of basic router, where it's going to decide, you just say, hey, if this, then this, right? So in
Yeah.
that case, I understand the concern here, but there is a level where we're getting to now where you can introduce some autonomy. As a developer, you don't actually know what it's necessarily going to do. And so then we start to introduce these terms like thinking, because it's like, I'm building the system, but I don't know necessarily precisely what the outcome is going to be. So maybe there's a different term to use. I don't know, autonomous thinking instead of thinking. I don't know. But yeah, Nuno, you can jump in and kind of take it.
Yeah, I was just going to add that I actually think it is a very helpful question to think about, because especially for less technical people, sometimes using these very human-like terms can maybe overpromise on what LLM applications can deliver. And my personal preference, at least, is always to underpromise and overdeliver. So it probably is actually helpful to not overuse those terms, because it can just create the wrong expectations. Then you end up thinking that ChatGPT, you can ask it literally anything and can do anything at all, and that's not quite right. That said, I do think our experience as humans is obviously rooted in what we can do as humans. So to some extent, there are no alternative terms. I don't know what's the alternative term to thinking that is not, human-like that doesn't have a human-like connotation. And I don't necessarily think it's super helpful to try and come up with new terms for everything. I think it's a middle ground.
Yeah, great answers from both of you. I maybe we'll do two more questions. Maybe let's start with this question from Brian. I will direct this question to Mayo, and then I will have a second question for Nuno to answer as well. So this one from Brian says, I was considering buying your book, Learning LangChain, but I see online that people are saying that LangChain has been changing so quickly and that the code samples in the book are already out of date. Are you planning to update the book or at least the samples? Is the book still mostly accurate? What is the thought on that?
Yeah, the book is accurate. We spent actually what, I think 16 months working on the book. I mean, in fact, halfway through, we revised the book to make sure it was updated. So,
Oh,
I mean,
okay.
halfway through writing the book. So, yeah, the book's up to date. There is a bit of hate towards LangChain. I understand, when you're a leader in any industry, there's always going to be competitors or other people trying to shoot you down. So, if you see any reviews or any comments like that, that's where it's coming from. The team's working really hard. The LangChain team updating the docs. It's really tough to keep everyone happy, and like I said, some people have just kind of decided to just keep attacking LangChain. So yeah, book's up to date. We will probably have another version at some point within the next year as well, but yeah, we put a lot of work into it. So and we're very responsive. If there's anything in there that you don't understand or some code that's kind of not working your end, we're you can contact us and we will try and help you work through it.
Yeah, I would also just add that for the past year and a half, we've actually, been super strict at LangChain about sticking to our release policy and minimizing the number of breaking changes we make, and always, giving people lots and lots of time, like years, to move off of deprecated APIs. So I would maybe caution you to, think for yourself instead of following all the stuff you read online.
Great. Thank you both for that. We have a question from Jonathan Fields that says, is there any research regarding how changes to the network architecture, e.g., multiple layers of attention mechanisms, compare to a programmatic approach using Python and libraries like LangChain? So what are your thoughts on the changes in network architecture versus using
Yeah,
libraries? Yeah.
I think it's an open area of research. So far, I think what we've seen is when you have a very specific use case that you have large data sets that you can fine tune the models on. That's super helpful. The only use case that we've seen so far that being applied successfully is code generation. I assume a lot of you want to build agents that are for something other than code generation. And in my view, it is actually a super interesting time right now because LLMs are, good enough with the right architecture and the right steps before and after to generate like a good enough answer that you can actually use them to kickstart your effort to build your data set that's specific to your use case. So I would actually see it as a huge opportunity to build agents that make use of LLMs out of the box as they are today with the right architecture before and after, and use that to build out the data set that you can then use to fine tune LLMs over time for your use case. So yeah, don't get sucked into all the FOMO about code gen agents. It's a lot of stuff to do out there.
Awesome. Fantastic. I think we have so many other questions. I don't know if we would like to spend more time on, I don't know, Jan, what do you think if we should uh
Maybe
have some more time?
maybe one or two more if our speakers are okay with that.
Yep,
Okay.
all good.
Okay. We'll do one or two more. We have so many questions here. This one is pretty popular. From Pascal. Talking about best practices, how do you test integration or unit test your LLMs and agents? How do you test them?
Yeah, it's a great question. Actually, having an architecture where you split your LLM agents into multiple steps like you do with LangGraph is super helpful for this because then you can unit test each step individually and even build out. So, and those unit tests can be both, regular unit tests that are used in regular software. So just, testing, what's the word I'm looking for? Like deterministic assertions that the output has this shape or whatever. And they can also be tests that use LLMs to judge the output. And that can be very helpful. And obviously, once you're happy with those, you can then move to test the agent as a whole, kind of as a black box. Like you put this stuff in on one side, and this other stuff comes out on the other side, and you test that's good enough for your purposes. But it's also an open area of research, so there isn't a definitive answer
Yeah,
today.
we have a whole chapter in the book dedicated to monitoring, evaluation, testing, essentially creating your data set of what you expect the outputs to be based on the inputs, and how do you benchmark that against whatever's generated through your system. So the three levels of testing would involve both monitoring, what's going on live. So when the user is using your application, designing beforehand, and then post production as well. So it's a whole other topic in itself. Yeah, I think that's it.
Yeah, that makes lots of sense. Please buy their book if you would like to learn more about the testing, because yeah, great answers. Okay, we have a question from Eric Silver about human in the loop. So this says human in the loop could also be seen as the user sending a prompt to the agent, and then when the agent is providing the answer, the user adds extra context or says some and then the user adds extra context or says something that was wrong. If so, does LangGraph support this interruption mid-planning feature? I'm not sure if that did that make sense?
Yeah, that makes sense, and that's something we
Okay.
support as well. So
Okay.
when you trigger a LangGraph agent, you can interrupt it at any point, and then it will cancel what it's doing, and then you can send additional context, like an additional clarification, if you suddenly remembered there's something you forgot to say. But human in the loop is also super important on the other direction, which is where the agent itself decides that it needs input from the user, and that's very helpful.
Yeah, that makes a lot of sense. Great feature. Um, we have 3 more minutes, so we're just going to do one last final question, which is going to be from Chintan Patel. And this question is, what are some selling points of choosing LangGraph as the underlying platform as opposed to a general purpose orchestration engine like, say, Cadence or Maestro and such? So, yes. Do we have any thoughts
Yeah,
on that?
so I think it goes back to what's different about building with LLMs. So because some of this stuff, like streaming intermediate output, is just completely useless if your application doesn't have an LLM inside it. Those more generic orchestration frameworks just have never thought about that problem, and they just don't have solutions to that problem. The same is true of human in the loop. Like, there's no reason why you'd make your deterministic workflow that you built with some generic workflow engine, interrupt itself in the middle because it doesn't have the ability to think, so to speak, that it needs more information. So that capability would have no purpose there, so it just doesn't exist. Yeah, the best reason to use something dedicated and thought through for LLMs is that we have the features that really only make sense for LLMs, like streaming and human in the loop, and obviously we have all the others too.
Yeah, I
Nice.
also add to that. It's how much customization and flexibility do you want. So obviously in my slides you saw the different. You have control of each node in the workflow. Every single step the agent's going to take. LangGraph enables you to customize that, to understand what the state's going to be at that point, to test every single step. So you might just want to build something very basic. You don't need all that customization. But if you want something serious, in production and an agentic application, then it makes sense to use LangGraph.
Absolutely. Great answers. Thank you so much, both of you. Thank you, Mayo. Thank you, Nuno, for your time. We appreciate everyone that was on the call today. We will be sending out an email after this with the recording, and also hopefully the link to the slides will be available as well. Yes, please feel free to follow both Mayo and Nuno online and check out all of our learning platforms just I think before you log out, there will be a survey that comes up. So please let us know if you enjoyed this session and how we can improve in the future. Some links are on the screen, so you can also take a look at those. But thank you so much for joining, everyone. Bye. Thank you. Yes, great presentation.